Hello, welcome back to our channel. Now we are going to discuss about previous year's MSET problems, and the topic name is the communication systems. Look here, the first problem is a carrier signal of frequency. They have given new one. This is the new one, and peak voltage is the V1. So this is about the carrier signal. Then modulated by message signal of that frequency is how much? Nu2. At that time the peak voltage they have given V2. Let M be the modulation index and V plus and V minus be the side bands produced which of the correct system. See, they have given four options here. We have to find out which is the correct, but the given data is they have given the frequencies V1 and V2. They have given peak voltage and carrier voltage V1 and V2, and they have given V nu plus and nu minus are the bands frequencies. So which option is the correct? See options what they have given: modulation index M equals to V1 by V2, and this is nu 1 equals to V plus V minus by 2. So V2 is here plus is there. Modulation index is greater than V2 by V1. So this is the wrong here, because modulation index, what is the formula? This peak V2 by V1, but they have given here greater than that one, means it is wrong, and here reverse they have given. So first and last options both are wrong. Then come to B and C. For that what we are doing, look at this paper side. The given data is look here. See, modulation M equals to, what is the formula? Peak value message signal by peak value carrier signal. Message signal clearly they have given that V2. So V2 by V1 just now, but in that options they have given V1 by V2. So we are not choosing that first option, but come to second one. Lower side band is how much, and upper side band frequencies what they have given? Nu plus equals to, we should add the two frequencies, nu1 plus nu2, and lower frequency nu minus equals to, we have to subtract that one. So from equations 1 and 2 what we are getting? See, nu1 equals to nu1 plus nu minus by 2, and nu2 is the in between minus is there. So which option is the correct option? So first and last options are not correct, but come to second one, you see plus is there. So this option is the right. So you can choose this one, and always you remember that modulation index, repeatedly they have given these questions. That formula is peak value message signal by peak value of carrier signal, V2 by V1. That formula we have to remember. Then come to second question. The second question is the modulation index. Look here. See, the modulation index used in amplitude modulation of message signal of peak voltage, how much they have given? 10 volts. At that time modulation index they have given M value is the 0.5. By how much peak value the voltage carrier signal be changed so that it gives the modulation index is a 0.8, keeping the peak voltage of the message signal same as before. See, try to understand this question here. The given data is see, the modulation index used in the amplitude modulation of peak voltage is how much? 10 volts. Then that modulation index is how much? 0.5. From this we can find out the carrier voltage. After that they have given modulation index is the 0.8. They are maintaining the same voltage of 10 volts only, but which is changing here? Modulation index is changing, means peak voltage is also changing, carrier voltage also changing. So we have to find out first one, second one, that carrier how much voltage difference is there. See, this is also very easy answer, looking like that is looking like a big answer like that. See, the given formula you know that AM by AC, modulated signal by carrier signal. First thing 0.5 equals to this AM 10 volts they have given. From this carrier how much potential is there? After simplification we are getting the 20 volts. But in second case, modulation index is the 0.8. Same peak voltage they maintain. Here carrier signal is how much? After simplification, 12.5. So 2 modulation index, you know the 2 carrier signal voltage, but the question is change is how much, means we have to subtract that one. Then we are getting that answer is how much? 7.5 volts. So it is also based on the modulation index. Then come to third question. Third question is very easy. Third question, look here. A message signal of frequency 10 kilohertz and peak voltage 15 volts is used to modulate a carrier frequency of 1 megahertz and the peak voltage is 30 volts. Determine the modulation index. Here no need of focusing on the frequencies, just we can focus what is the peak voltage here, 15 volts, and the carrier voltage is how much? 30 volts. But what we should find out here, from this we have to find out the modulation index. Already you know that what is the modulation index formula. You know that modulation index formula is, look here, amplitude message signal by amplitude carrier wave signal. So 15 by 30 how much? 0.5. Only confusing purpose they have given frequencies. No need of using here. Simply we have to remember this modulation index formula, and here you have to find out the modulation index. See how much you should give the preference to modulation index. So they have repeated this one 2020 shift 1, and the second one is also 2020 shift 2, and the third one is the 2020 September 10th they have given this one. Then come to fourth one, it's very easy. Look this, television signals are received through skywave propagation. Reason, the ionosphere reflects electromagnetic waves of frequencies in the range of 3 to 30 megahertz. From this, what you are understanding, always you remember that for sending the television signals we require the space wave propagation, because that frequency range is how much? Above how many megahertz? 30 megahertz. So skywave propagation is not at all suitable for television signals. So first one is clearly you can say that it is the false. Then second one, you see, yes, ionosphere is the layer from the skywave only. For the skywave propagation, you know that is used as a reflector. So this is the true. It can be, you can use this propagation from 3 to 30 megahertz. Then come to next question. The given data is what for next question? Look, this is also very easy. See, the electromagnetic waves of frequency. The electromagnetic waves of frequency, how much? 6 gigahertz. Giga means 10 to the power of 9 gigahertz are used. For that is for what? FM broadcast, TV communication, satellite communication, cellular, mobile radio. So which one we are using? Satellite. For satellite communication we are using, that is for 6 gigahertz. So simply this is the theoretical question only. Then come to seventh one, it is also very easy. The function of detector is to demodulate the modulated carrier wave, and the steps for this process are, look here, what is the modulation? We have to strengthen the signal. Carrier signal is combining with that one, and it will become like a weak signal, it will become strong. But while receiving that, what happens? Once again they have to do the demodulation. They have to divide that carrier signal and original signal. That process is called what? Demodulation. That is called what? That answer is which option? Demodulation and filtering, it's wrong. Second one is the demodulation and rectification, it's wrong. Third one you should remember that rectification and filtering. That process is called what? Rectification and filtering. Then come to 8th question. See, don't leave this chapter, very small chapter. Okay, a message signal of frequency, they have given 50 by 5 kilohertz, and the peak voltage here also modulation index only 5 volts, used in a modulated carrier signal of frequency how much? 1 megahertz, and peak voltage is how much? 20 volts. The question is, the modulated index is, once again we can go through the which formula here, simple thing, we can take it. Answer is how much? See, look here, they have given that message signal voltage is how much, peak voltage clearly they have given 5 volts. This is the 5 volts, carrier voltage 20 volts. So 5 by 20 is how much? 1 by 4. So answer is how much? 0.25. So simply you can able to do this one. Then come to 10th question. Come to 10th question. Look here. See, the transmitting antenna placed at the transmitting antenna placed at the top of a tower has a height. See, simply you should remember that here transmitter height is how much? 45 meters. Then the distance between the receiver and the transmitter is how much? 40 kilometers. And the radius of the earth they have given 6,400 kilometers. The minimum height with the receiving antenna is to be placed for satisfactory communication LOS mode. See, question is looking very big, but in that nothing is there. We have to remember one formula for doing this. That is we have to write the given data first. Look here. See, height of the transmitter is the 45 meters. Distance between the receiver and transmitter is the 40 kilometers. Radius of the earth they have given 6,400 kilometers. This formula, distance D belongs to distance between the receiver and transmitter. This formula is what? Under root 2 R HD. HD belongs to height of the transmitter plus under root 2 R HR. This small r belongs to, this last r HR means height of the receiver. This R is representing the radius of the earth. You have to remember, sometimes they are giving, sometimes they are not giving. That is called what? Radius of the earth 6,400 kilometers. We have to substitute. 40 kilometers means 40 into 10 to the power of 3. So under root 2 into 45 into 6,400 into 10 to the power of 3. Because kilometers, no, we are converting into meters. We know 2 value, R value, H2 value. But here 2 into, we don't know about this HR. HR only we can find out. HR means not human resources here. It is belongs to height of the receiver. So after substituting all these and simplifications, what we are getting? Height of the receiver is how much? 20 meters. Height of the receiver equals to 20 meters. Not only this one, 11th question also same thing. See, limited formulas you have to remember. See, they have given, this is 2019. A transmitting antenna has same HD is 11th problem also. They have given that height of the transmitter is how much? 20 meters. We have to find out the height of that receiver antenna. HR we have to find out. Same formula we are using. D equals to under root 2R HT plus under root 2R HR. Here 40 kilometers means 40 into 10 to the power of 3. This is under root 2 into 6. This is the 6.4 into 10 to the power of 6 means nothing but 6,400 kilometers radius of the earth. And they have given height of the transmitter is how much? 20. So after simplification we are getting x value how much? 45 meters. That is the height of the receiver. Then 12th question, you look here. Carrier wave are used for communicating signals over a long distance because, see, this is very important thing. Carrier waves can be generated very easily. It's wrong answer. Low frequencies cannot be easily modulated by carrier waves. No, it is also wrong. Low frequencies can be transmitted over long distances. No. See, D. Carrier waves generated at high frequencies, then only it is supporting that original signal, can be transmitted over long distances. So the option number D is the right. Then come to next question. Here also same model they have given, this same model. See, height of transmitter antenna is 49 meters. Then receiver antenna is also they have given 64 meters. They have given HT and HR both. What should be the maximum distance between the line of sight signals means same formula we can use. D maximum equals to under root 2r ht and 2r hr. See, 49 meters, substitute all values. After simplification, how much distance is there? 53.6 kilometers. Okay, thank you everyone. Please subscribe my channel and share my channel too with your friends also.